All right. Well, how's everybody? Am I having a good first day back? The first day back is always the hardest, especially after a big vacation. Yeah, I did. Yeah, it does. Yeah, yeah. I got to give you that. It looks shiny. Let me go ahead and get started. So because we were out for a week, and I hope everybody had a great break, you know, you're rested and relaxed, ready to come back and finish up, including today, we've only got 14 school days until your next vacation. So a little over 2.5 weeks. It is not a lot of time, but we do have a little bit to do between now and then. So first thing, because we were gone over a week, the administration asked that we go ahead and cover the expectations again very quickly. So number one, cell phones got to remain out of sight. This also includes the Bluetooth earbuds, so you've got to keep those put away. If we do have any downtime, anything like that, wired earbuds are perfectly fine if you connect them to your Chromebook, but cell phones and the wireless earbuds, we got to keep those put up, okay, please. Also, hallways, you know, go ahead and try to make your way to class as quickly as possible. Apparently, the week before Thanksgiving, the tardy number of tardies went quite high, so they're trying to pull that back down. Smart Pass, if you're going to go to the restroom or any other location, you do need either your permanent or a temporary badge. Lunch, of course, we're closed campus, but nobody would leave campus, right? Totally. And as always, as Westerners, we want to show our grit, which stands for growth mindset, respect, integrity, and teamwork. And everybody in here would have known exactly what that acronym meant if I hadn't had that up, right? Exactly. Okay. So that is the admin part of it. So let me kind of give you an idea of what's going to be happening this week. So today, we're going to start off with a little bit of review. It's probably going to take about half the class because right before we left for Thanksgiving break, we were talking about complex operations. So I want to go ahead and refresh your memory on those. That's one of the papers you picked up today. After that, today into tomorrow, we're going to look at how to change a standard form equation into vertex form. Okay, then on Wednesday, we're going to review because on Thursday, you've got your second test. The second test of the 9 weeks. Okay, so it's going to be solving quadratic equations using whatever method you prefer, but it's also going to include these imaginary numbers and complex operations. Okay, so again, that review I think does a pretty good job of showing you what skills you need to practice, but we'll take a look at that on Wednesday. I'll have that posted, and then we'll just get through the rest of the week and the next week, get done compositions, inverses, and we're getting close to being done. So questions. Okay, well, let's take a look. So this right here, this is the homework assignment that you would have gotten for, should I leave the live off or on? Off, okay. Every other class has been wanting it on today. So we're going to go ahead and run through a couple of these, definitely not all of them, but there are potentially some questions on your exam that could use this information. So we're going to skip around, but we're going to start with number one. Now remember, a complex number is going to be of this form, a plus bi, where a is the real portion and bi is the imaginary portion. So when you add or subtract them, then we get what's called a complex number. Okay, so in number one, I want to take the complex number 11 minus 7i, and I want to add 2 minus 5i. Well, there's nothing to distribute, so I'm just going to drop the parentheses. 11 minus 7i plus 2 minus 5i. And then we just go ahead and combine our like terms. 11 plus 2. Okay, 13. And then negative 7i minus 5i minus 12i. Okay, now remember, I'm not going to be a stickler about this. There will be professors and teachers who will, but we do prefer that the real portion come first, but if you were to put negative 12i plus 13, I'm not worried about it. Okay, you're going to be just fine. There you go. Now, how is number two different? You do have to distribute something for the second parenthesis. So the first one, negative 6 plus 10i. So this is going to be a minus 1 plus 2i. Okay. And then let's just combine our like terms. What's a negative 6 minus 1? Negative 7. And how many i's do I have? Plus 12i. Go. Adding and subtracting, very straightforward, nothing to it. Okay, good, good, good. Well, let's go ahead and skip to number 5. Number 5 is where we start talking about multiplication. So if I want to multiply two complex numbers, we're again going to use FOIL. What does that stand for? First, outside, inside, last. Okay, so I'm going to go ahead and say the terms. You folks give me the product. Okay, so 7 times 4. 28. 7 times 3i plus 21i. 9 times 4. 4i. And I times 3i plus 3i squared. There we go. So here's my first, outside, inside, and last. That's the acronym that explains how I'm going to multiply these two binomials. Okay? And now we just go ahead and start combining our like terms. But when you start dealing with multiplication, this is where one of your definitions is going to come into play. Does anybody remember what is I squared? Remember, I squared is -1. So when it says plus 3i squared, this is really plus 3 times -1, so I'm just going to go ahead and say minus 3. Okay. Or if anybody would like me to actually write that out so you can see it, I will definitely do that. Okay, and then now we just combine what we have. 28 minus 3 will give me 25. And then 21i plus 4i plus what? 25i. There we go. Okay, so it's been about a week and a half, but is this starting to come back to folks? This is what we were doing right before the break. Any questions? Okay, again, let's go ahead and skip around. How about number 9? Okay, so 5 minus 2i times 2 plus 7i, and then I want to subtract 2i times 3i squared. So you're probably thinking to yourself, Mr. West, I know how to do this. Okay, so let me give you a couple of minutes. Let's see if you can simplify this expression. We're on number 9. $45. Okay, so you may not have finished, and that's okay. But here's what you should be getting. 24 plus 29. How many folks were able to get that? Okay, so a few hands. Okay, all right. Okay, let's talk about it. Let's run through. So the first thing I would do, let's go ahead and FOIL these two complex numbers together. Okay, so we'll do this like we did a moment ago. Okay, 5 times 2, so that's 10. 5 and negative, or positive 7i plus 35i. Negative 2i times 2 minus 4i. And then negative 2i times 7i. Negative 14, what is it? I squared. Okay, so first outside, inside last. Always the same. Okay. Now for the other part here, before we multiply by negative 2i, we got to take care of this. So we have a negative 2i times, well, a 3i quantity squared would be 9i squared. 3 squared and then the I squared. Okay. So there's a couple of different ways we could do this. We could go ahead and now replace the I squared with a negative 1, or I could just multiply it together and simplify I cubed. Which one would you folks prefer? I cubed? Okay, let's do I cubed. So if I go ahead and multiply these together, what I've got now is a negative 18 I cubed. Okay. Now, does anybody happen to remember what is I cubed? It just equals negative I. Oh, I forgot the negative on that. Negative I. You remember that little shortcut I gave you when you're talking about powers of I? I1, make the two middle negative. Okay. Or you could look at it like this. I cubed is equal to I squared times I. See, I just broke 3 apart into 2 plus 1. And we know that I squared is a negative 1 times I. So see, I'm still getting negative I. So if this is really a negative 18 times I cubed negative I, well, wouldn't this just be a plus 18i? And is there any other part of this I can take care of before I start simplifying, combining like terms? There's a negative 14i squared. Remember, that I squared is negative 1, so this is really plus 14. 14, negative 14 times negative 1. Okay, and then now we just go ahead and start combining our like terms. So let's see here. I got 10 and the 14. That's where I get the 24 from. Okay. And then I've got 35i minus 4i. That's a 31i plus 18i. I put 29? Oh, that should be a 49. I'm sorry. First day back. 49i. I put 29. Did anybody notice that? A few folks. Okay. All right. That's my fault. 24 plus 49i. Okay. Question. The I1. So any powers of I, okay, it goes I1, make the two middle negative. So what you're looking for are the remainders. Because it was these 4 terms over and over again, you were dividing by 4. That means we could have remainders of 0, 1, 2, or 3. So we have a remainder of 1, 2, 3, or if it divides evenly. So for example, if I wanted I to the 20th, okay, what's 20 divided by 4? 5 with no remainder, right? So because there's a 0 remainder, I know that I to the 20th is just 1. What if I wanted I to the 29th? Okay, well, let's see, 29 divided by 4? Okay, so 7, because 7 times 4 is 28, but here's what's important. The remainder is 1. So with a remainder of 1, I to the 29th would just be I. Okay, remember that's how that worked. I1. Okay, with the two middle negative. It's silly, but it does work. Okay, cool. All right, well, let's take a look at number 10. Now, we're going to start looking at division. Negative 4 over 7i. So we don't like the fact that we have an imaginary unit in the denominator. Removing it, that's what we call rationalizing. So we're going to rationalize the denominator. Okay, does anybody remember how I did that? How would I get rid of that I in the denominator? I got to multiply it by a version of 1, but what is that? It's not the reciprocal, because I want to keep the same value. Whatever negative 4 over 7i is exactly, I want to keep that value. So if it's a monomial like this right here, I'm just going to multiply by I over I. Because remember, what is I divided by I? That's 1. What happens if you multiply anything by 1? Okay, it stays the same. So negative 4 times I, that's a negative 4i, over 7i times I, that's a 7i squared. Okay, and see, the whole point is to remove I from the denominator. Well, what's I squared again? Negative 1. So this would be a negative 4i over 7 times negative 1 would be a negative 7. And is there any other part of this that I can simplify? Yeah, what are those two negatives going to do? Yeah, they're going to cancel. So I should have a 4i over 7. Now, it doesn't matter having an I in the numerator. That's perfectly fine. We just don't want one in the denominator. Okay, we call that rationalizing. Okay, let's go ahead and do another one of those. Let's skip to 12. Okay, so I've got 8 plus 4i over 2i. You want to try this one together or on your own? Together, okay. So you're still dividing by a monomial, a single term. So I'm going to multiply the numerator and the denominator by I. Okay, same thing, times I over I. Now, in the numerator, we are going to have to distribute. Okay, so 8 times I will give me 8i, plus 4i times I is a 4i squared over, and then 2i times I, that's a 2i squared. And remember, I know we've said this quite a few times. What is I squared again? I always forget. That is negative 1. So would everybody agree that this numerator, 8i plus 4i squared, wouldn't that just be negative 4? This don't let me right. Negative 4 plus 8i over 2i squared would just be negative 2. Now, again, if you kept it as 8i minus 4, that's fine. Not worried about that. Okay, but would everybody agree with what I did? Is there anything else that I can do? I can still simplify. We're going to break this apart into two fractions. So I'm going to say negative 4 over negative 2 plus the 8i over negative 2. Okay. So what should my answer be? Negative 4 divided by negative 2 would give me 2 minus 4i. Is it coming back to us? Okay. Now you'll notice numbers 11 and 13, they're the same type of problems. Okay. I want to go ahead and move on to number 14. Why is number 14 different? Okay. That denominator, we're not dividing by a monomial anymore. It's a what? It's a binomial. There's two terms. So if I want to go ahead and rationalize something like this, I can't simply multiply by I over I. This is when I have to use the what? Starts with a C. The conjugate. Remember, these are groups that are A plus B times A minus B. Okay, same terms, 1 plus, 1 minus. Okay, so what's the conjugate to 1 minus I? Okay, what is that? Brianna, what do you think? 1 plus I. Here we go. And then now we just have to multiply and we'll simplify. Replacing I squared with negative 1 as we come across it. Okay. Now, you want to try this one together the rest of the way, or you want to try this one on your own? together? Okay, let's do it. Okay, so up top, I've got to distribute. So 6i times 1, well, that's 6i. 6i times I, that's going to be a plus 6i squared. So all I did was go ahead and distribute that 6i. Okay. Now, below, you're still more than welcome to go ahead and FOIL those together. First outside, inside, last. But remember, if you're dealing with conjugates, you only have to multiply the first and the last. Okay, so the first, 1 times 1 will give me 1, and the last, negative I times I would be a minus I squared. Does anybody want me to do the full multiplication to show that's what I'm going to end up with? Okay. Well, let's see here. Up top, what is a 6i squared really? Negative 6 plus 6i. So is everybody okay with what I did? I just replaced 6i squared with the negative 6. 6 times negative 1. Okay. Now down below, 1 minus I squared, well, that's really 1 minus a negative 1. So what's my denominator? 2. Remember, because when you're subtracting a negative, it turns to addition. Okay. And now I'm going to do just like I did on the previous one. I'm going to go ahead and break this apart so that I can simplify. So this is going to be a negative 6 over 2 plus 6i over 2. So what's my final answer? Negative 3 plus 3i. There you go. That's all there is to it. Anybody having a hard time? Okay. Anybody lost? Okay, I got one more, number 15, that I wanted to take a look at. Okay. Number 15. So I want to take 4 plus 10i divided by 3 plus I, and I want to rationalize this. Okay. So let's see here. Penny, what is the conjugate for 3 plus I? Ooh, no. Remember, there's only one thing I change about it. That plus becomes a minus. So this one right here, this would be 3 minus I over 3 minus I. Like if I wanted to rationalize number 16, okay, the denominator is a negative 1 minus 4i, so I'd multiply by a negative 1 plus 4i over a negative 1 plus 4i. That's always the conjugate of the denominator. Okay. All right. So try this one on your own. Okay, I just went ahead and gave you another example for 16, but right now we're working on 15. So you will have to go ahead and FOIL the numerators together. You don't have to do the entire FOIL process when it comes to the denominators because they're conjugates. Okay. Let's see if we can come up with the same answer. Coming up on 1 minute. I'll go ahead and tell you numbers 17 through 22. We didn't talk about those on the original notes, so don't worry about those. Nothing like that's going to show up on the exam. I mean, it's good to know, but we don't need to take time for that. Yeah, it feels nice when you first walk in out of the hallway, but then you're in the oven for a while, and then you walk out in the hallway and it feels good. Yeah. Can't get those temperatures right. Okay, so let's go ahead and run through this and see if we're all on the same page. Okay, so 4 times 3 will give me 12, and then minus what? Minus 4i, okay, plus 30i, and then minus 10i squared. That's what we should have gotten up top when we FOIL. Everything's looking familiar? Okay. Now remember, the bottom two denominators, they're conjugates, so I only have to use first and last. Even if you do the outside and the inside, they're going to cancel anyway. Okay, so it's completely up to you. So 3 and 3 will give me 9, and it looks like I'm going to subtract I squared. Okay, well, let's go ahead and simplify this. So this minus 10I squared, that would just be really plus 10. Negative 10 times negative 1. And this 9 minus I squared, that's really just 9 plus 1. Is everybody okay? So let's see here. Up top, I'm going to have 12 plus 10, so it looks like I have 22. Plus what? 26I over 10. Okay. And is there anything left that I could do? I can simplify it, so I'm going to break it apart. So 22 tenths plus 26I over 10. Okay. So it looks like I'm going to get 11 fifths plus what? Was it? How many I's? 13. 13I over 5. So that answer is perfectly acceptable. You can just go ahead and leave it like that. You notice they've got the same denominator, so if you just wanted to go ahead and pull them back together, 11 plus 13I over 5, either of those are going to be good. Okay. How many folks got that? Okay, good, good. That's quite a few hands going up. Did anybody have any questions? Any part of this, we're not sure where I got a value from. Okay, fantastic. All right, well, like the review coming up on Wednesday, you're going to have several problems, like we skipped a few here. So you still got some practice if you want to take a look at that. Let me go ahead and set this up for the next class. And then let's go ahead and look at that other paper that you picked up on the way in. Okay. Okay, so a quick intro. What are we going to be doing in this lesson? We're going to be taking that standard form, ax squared plus bx plus c, and we're going to be rewriting it to get our vertex form, a times x minus h squared plus k. Remember, the one condition, a must equal 1 in order to complete the square. If it equals something besides 1, we're going to divide it out. We're going to pretend it's a GCF. Okay, so let's go ahead and get to it. Okay, perfect square trinomial. So a trinomial of the form ax squared plus bx plus c, where b divided by 2 squared equals a times c. And you might recall that when we complete the square, half of b squared, this right here, that's completing the square. That corner of the room. Here, let me do this. Completing the square. There we go. That's what we actually refer to as completing the square. Half of the linear coefficient squared. But that's going to equal the product of A and C. Okay, well, let's take a look at these. It says factor the following. All of these are going to turn out to be perfect square trinomials. Now, what are we talking about when I say a perfect square trinomial? That means I'm going to notice something when I factor it. What is that? Okay, well, let's factor it and see what happens. I need two numbers that'll multiply to give me 16, but those same two numbers have to add to give me 8. 4 and 4. Okay, so that would be x plus 4 times x plus 4. So what makes this a perfect square trinomial? The two groups are what? They are the same. That's what we're looking for. So this x plus 4 times itself, we could go ahead and rewrite that as x plus 4 quantity squared. Because that's how we're going to get the vertex form from standard form. And let's take a look. Let's use this definition up here. The linear coefficient is 8, right? So let's go ahead and test that little rule. So 8 divided by 2 squared should equal a times c. Well, what's the value of a here? 1. And what's c? 16. Okay, well, let's see. 1 times 16 is definitely 16. 8 divided by 2 is 4 squared. That's a quick way to test if it is going to be a perfect square trinomial if you don't just factor it. Okay. The same thing is going to work for all of those. Okay. All right, so let's try a squared plus 2a plus 1. Two numbers that'll multiply to give me 1, but add to give me 2. In fact, what's the only factor of 1? 1. So wouldn't it have to be a plus 1 times a plus 1? Or a plus 1 quantity squared? Well, now that we realize we're dealing with perfect square trinomials, instead of my writing out the product, let's just go to the squared group. What would m squared minus 18m plus 81 be? What would I square to get that? Okay. Would it be plus or minus? One thing you'll notice, it's always the same sign as your linear term. So because that's a minus, what two numbers will multiply to give me 81, but also add to give me negative 18? Negative 9. So m minus 9 times m minus 9. Okay. So what's the other one going to be? P squared minus 10p plus 25. What am I going to square here? P minus 5. Yeah. Because once we get that perfect square trinomial, that's what we need to do in order to get the vertex form. Okay, so there's a whole list of instructions right here to go ahead and run through. If you ever forget what we're doing, you can just read through those, look at some examples, but I think it's best, let's just get to an example and see what we're doing. Okay, directions: write each function in vertex form and give the vertex. Okay, so number 1, f of x equals x squared plus 4x plus 4. Now, this is different than what we were doing before. We are not solving an equation. I'm simply rewriting the equation. Like, say, I'm changing standard form of a linear function to slope-intercept form of a linear function. They're both the same line. They're just different versions. Okay? So this x squared plus 4x plus 4, what you have to realize, we're going to be working with everything on one side of the equation. You're always going to want to start, okay, by putting parentheses around the quadratic and your linear term. So x squared and x. Okay. Now this one is all ready to go because what's a? Remember, a has to be 1 before you do anything, and that's what we got here. So f of x is going to equal, so I'm going to go ahead and put parentheses around x squared and 4x. But then I'm going to put a plus and a little bit of room because I'm going to have to complete the square. And then outside, I've still got this plus 4. Now, this is where completing the square comes in. That linear coefficient b, this is what I'm going to divide by 2 and square. Okay, so let's see here. 4 divided by 2 squared. What's that give me? Okay, that's going to be 4. Everybody agree? So if I'm going to go ahead and add 4 here, I've got to subtract 4 here. Why would I do that? Remember, think about the old rule. When you're dealing with an equation, whatever you do to one side, you what? You have to do to the other side, right? So if I add 4 on the left, I have to add 4 on the right. But are we working across the equation? We're staying on the same side. So I've got to make sure that it's balanced. If I go ahead and add a 4, I've got to subtract 4 to balance out what I did. Okay. Now this right here, this is now a perfect square trinomial, just like we had up above. Okay. Two numbers that'll multiply to give me 4, but add to give me 4. What would that be? It'd be 2 and 2, right? So wouldn't this be x plus 2 squared plus 0? Now, normally you wouldn't have to write the 0, but I want you to see what our vertex is going to be. It's not going to be wrong if you do write that. Okay. And here we go. There's a times x minus h squared plus k. What's the vertex here? Remember, which one did I have to take the opposite of? Was it h or k? Only h. So here I've got h is a positive 2, so I'm going to put a negative 2. K value stays as is. There you go. Now, these look like two completely different equations, but if I were to graph them, they're both going to be the same parabola. Exactly. One's in standard form, one's in vertex form. That's all we're doing here. Okay. In fact, I'm going to go ahead and prove it to you. I'm only going to do it on this one, but let's go back to x squared plus 4x plus 4. Okay. Does anybody remember how we originally found the vertex for a standard form? Does anybody remember that little expression? It's been a while. Does this look familiar? The opposite of b over 2a, f of the opposite of b over 2a. Let's see what happens if I find the vertex. If these are truly meant to be the same, what should happen? You should get the exact same vertex. So here's a, here's b, here's c. So what's the opposite of b? So that would be negative 4 over 2 times a is 1. So what's negative 4 divided by 2? Negative 2. Isn't that exactly what I got right there? Now, how do I find the corresponding y value? What do I do with that negative 2? We just plug it back in. Okay. So x squared, f of negative 2, this would be x squared negative 2 squared plus 4x plus 4 times negative 2 plus 4. Well, let's see. Negative 2 squared is a 4 minus 8 plus 4. What's that give me? 0. It's still giving me the same information. Okay. Questions? Okay. Now, you don't have to do this. I just wanted to go ahead and connect it back to something that we had done previously. Okay. Well, let's take a look at number 2. Okay. All right. Number 2. I want to take x squared minus 8x plus 18, and I want to rewrite it in vertex form. Okay. Right, Penny? Right. Okay. So first off, can I even do this? Rima, what do you think? Can I go ahead and complete the square? What's that one condition? K has to be what? K's got to be 1. And that's exactly what I see here, so I can get right into it. Remember, I'm going to isolate the quadratic and the linear term. So I'm going to go ahead and say x squared minus 8x. Now I'm going to put a plus and a little bit of room because I'm going to complete the square. And then outside that parentheses, that's what I'm going to go ahead and put the plus 18. So what will I divide by 2 in the square? That negative 8. Okay, well, let's see here. Negative 8 divided by 2. I'm going to square it. So that would be a negative 4 squared. So what do I get? 16. So by completing the square, if I put 16 here, what's going to follow the 18? Minus 16. See, you have to balance the side of the equation. If I suddenly add a value, I've got to subtract it as well. Okay. And what is this that I just created? Circle P. That's a perfect square trinomial. In fact, what squared group would I get out of that? What two numbers will multiply to give me 16 but add to give me negative 8? Negative 4 and negative 4. So it'd be x minus 4 squared. What's 18 minus 16? Plus 2. There you go. There's your vertex form. Okay, so A times x minus h squared plus k. So what's my vertex? Okay, positive 4. So negative 2? No. The k you leave alone. So positive 4, 2. That's it. That's all there is to it. That's not so bad, right? Okay. Standard form to vertex form. Am I losing anybody? Okay. All right, well, let's go ahead and try another one of these. Now, does anybody notice anything different about number 3 than what we did with 1 and 2? There you go. A is not a positive 1. Okay, so here's what I'm going to do. I am going to go ahead and still isolate the x squared and the x, but if A is anything, even a negative, besides positive 1, I'm going to factor that out. Okay. So I'm going to go ahead and say f of x equals. So I'm going to factor that negative 1 out, and then I'm going to start my parentheses. So I'm now going to have x squared minus 6x. See, by pulling out the negative, it changed the sign of both of those. Then I'm going to say plus a little bit of room, and then outside the parentheses, that's when I got the minus 5. Okay. So what will I complete the square with? That negative 6. So let's see here. Negative 6 divided by 2 squared. What am I going to get out of that? 9. So here's where you got to be careful, and it's really easy to forget this. So I'm going to go ahead and put a 9 here. So I'm going to add a 9 here. Whoa, whoa, whoa. Why wouldn't I have subtracted that? Remember, you're not really adding a 9. You're adding a 9 times negative 1. So negative 1 times 9, you're actually subtracting 9, which is why I had to add it. Remember, you've got to do the opposite of what you got. Does that make sense? It's real easy to mess that up. Okay. Everything else is still the same. You got yourself the perfect square trinomial. Okay. So f of x equals, let me go ahead and go back to blue. So what squared group do I have? What two numbers are multiplied to give me 9, but add to give me negative 6? So it'd be x minus 3 squared. Negative 5 plus 9? Plus 4. And don't forget about that negative 1 we factored out at the very beginning. So there you go. And what is my vertex? Okay, so the vertex would be a positive 3. And then what? 4. There you go. That's it. So converting from one to the other, it's not terrible. It's not a lot of work. Okay. Any questions? Anybody having a hard time? Okay. So here's what I want you to do ahead of tomorrow. We're down to 5 minutes. So this number 4 right here, take 2x squared minus 12x plus 13, rewrite it as vertex form. Okay. Now, before you complete the square, you're going to have to factor out what? The 2. Remember, A has to be 1 if you're going to complete the square. Okay. All right. So try that ahead of time for tomorrow, and we are good. Fantastic. Okay, let's go ahead and move that down. That's ready to go. Okay.